This video will serve as a tutorial on how to utilize the PRV capabilities in the vCalc program. To demonstrate it, we have a design area with a couple different sets of sprinklers that are flowing. Up on this side here, we have some K14 ESFR sprinkler heads, and then down off this side over here, we have some K56 sprinkler heads. Now, if we were to go into our view design area here and sort by pressure ascending, we can see that on the K56 heads, we only needed about 15 GPM, but they're all flowing over double that. They're in the mid-30s, and that is because our K14 design area farther down the system is what's driving the demand, and we can see that because our most remote head is this S11 right here, operating at the minimum pressure we asked for from the K14s, and we can go use that locate button to go look at that. And again, that makes sense. Most remote, one of those on this tree right here at the very end of the system. So one method of trying to balance this system would be to attempt to use a PRV. So here I have a couple placed in the model here. It's a Zern-Wilkins version. I'm not sure we'll operate exactly within their pressure requirements, but just as a demonstrator on how to utilize the functionality, we're just going to have these here to placehold what we're looking at. So I have two nodes for those. I have one called PRV 56, so that's for the K56 heads, and then I have one called PRV 14, which is feeding the K14 heads. Now if I go into the OpenUI 3D viewer here, and then we come in, we can see that this is the little segment over here. We can see the flow, PRV 14, PRV 56, and we can see the pressures they're operating at. Now, just for demonstration purposes, we'll start by causing some problems for ourselves by kind of misusing the PRV function. So the first one we'll focus on is the K14 PRV. So right here, this is telling us that in our demand scenario, which is what we're operating in, that node would have to be at a little over 86 psi to meet the minimum flow requirements that we've asked for. So if we were going to misuse the PRV function, we can come to the program here. We can add a PRV in, and you can do this via the button up here, which I'll show later. But this works on the desktop as well. You just add a PRV. We'll put it at the PRV 14 node, and to start, we'll put it at 100 psi maximum pressure, and we'll see that that has no impact on the results. We're still operating at the same 86 psi at this PRV 14 node. This is as expected. The pressure is above the minimum that we needed, so it's not going to do anything. Now, if we were to go and lower this and say that it's got a maximum pressure of 80 psi, what we're going to do is get an error here telling us, hey, all these sprinklers are not flowing, and the status message is going to tell us that the calculation probably didn't converge, so we need to maybe try more iterations or revise our input. And the issue in this specific case is that we need to revise our input. We've asked it to limit downstream pressure to basically 80 psi, but we know from the demand perspective we needed 86 minimum. We've asked for an impossible scenario, so this is just going to cause us problems, and it's never going to be able to come to a result because we're telling it, hey, you can't go above 80, but we know it needs above 80. And as soon as we get rid of that, we're back to our calculation set. Now, if we want to utilize this for the other section, so all the K56 heads that are flowing down here, we can do that. So we can see that we're coming in, and it's at about 84 psi currently, and this is all getting driven by the K14 heads on the other path. So we can go add a PRV. We'll add it at the PRV 56 node, and we'll just put a number in here. We'll try 50 psi. We can see that it worked fine. We got a result back. We can see it's still coming in at about 85 psi here. but what it's going to be doing is limiting all the downstream pressure. So all these nodes after that are going to see this as if it was operating at 50 psi at this node, and we can already see that it dropped our flow requirements as well, because all those heads downstream are seeing a lower pressure. So if I turn our flow labels off, but I turn all of our pressure labels on, we can see that we go from 85 psi, it gets dropped to our 50 psi maximum. That Zern valve has a loss curve in there as well, so we lose a bit more pressure. And we can see that N13 here is down to about 31.74 psi. So again, it's doing exactly what we asked for. It's limiting the pressure. We gain a little bit as we lose elevation, and if we look over here, we're still operating quite a bit above our minimum flow, so we could actually play with this maximum pressure a little more. So we try 40 psi. We can see that that helps some. We can continue trying to limit it to reduce the amount of flow that's coming down this pathway over here. The other thing that can happen is if we get a little too greedy, we can actually start driving the demand for the system based off of what we've limited downstream. So if we go back to our design areas, sort by pressure ascending, we can see that these are all now still above our minimum flow. We're still getting driven by that S11, but there is a scenario here where we could actually unbalance the system and start driving the K14 heads off the K5-6 heads. But basically, by doing this approach, we can minimize the amount of water getting flown down on this side of the system and balance the system out better. Now, I showed just adding it in the UI where we already knew the nodes that we want to have here. You can do the same thing within Revit. So I'll just get rid of that PRV that I had added, close this out. So if I wanted to add a PRV in Revit, I click the PRV button, and then I'll use the Pick Nodes option, and then I'll go grab that PRV that I want to add. You could pick more than one, click Finish, and now it's in my table, but I picked the object in Revit. I didn't have to know the name of it, and then I can just provide the maximum pressure over here. So we could try something like a 20 psi, and then continue revising from there. Again, that may not be within the operating characteristics of this specific valve I'm showing with, but it's just a demonstration of how you might go about utilizing the inputs there. Now, as far as the results go, if we go to create submittal, and then we print this out, and I bring it over from my other screen here, when you do have a PRV present, it will show up in the PRV column, and if it's active, it will say that it's active, so we can see it's at 20 psi active here. If we scroll down a little bit, we can see how it gets reported out in the printout. So it says the PRV is active, it's shedding 66 psi, 67 psi. We're losing another 11 psi-ish off of the loss curve, and that's just accounting for where the pressure differential comes from here. So that's kind of the basics of how that happens in the program. I also have a very simple little version here that'll pull up in the desktop. So we can see we've got a system here, and this is running a supply side calc on a very simple little system that I've put together. So you can see it just comes out to a T, and then it splits each way. And I'll turn off our pipe labels here, turn all of our pressure nodes on. So here we can see I have a PRV1, a PRV1 out, a PRV2, and a PRV2 out. And then in this situation, there's basically two sprinkler heads, if you will, both flowing. So they're K25 heads, and they're just going to flow at whatever pressure reaches them from a supply calculation perspective. So just to demonstrate a little clearer what that PRV capability is doing, I'll add a PRV at this node over here. So I'll go into my UI, go to PRV, add a PRV, and then at PRV1, I'll give it a maximum pressure of 25 psi. And if we go look at that again, we can see that PRV1 still sees that 58.5 psi come in, but you can see that PRV1 out is seeing this basically as if it was at 25 psi here, we lose 0.01 psi just due to flow and friction loss. And then we see our node here at 24.99 psi, whereas the other side was not affected by it. The other thing I'll note is that these are heavily influenced by what is on the start column and what is on the end column. So when the PRVs are being taken into account, it is the start to end flow that sees the pressure offset. So we can see here for our row with PRV1 and PRV1 out, it starts at PRV1 and it ends at PRV1 out. So basically, if this was in reverse, you may not get the results you're looking for in the system. We can see this up here with N1 and N1 to PRV2 as well. So if I were to actually go and add PRV2 here with the same characteristics, I'm not going to get any results, and that's again because of how the columns are oriented. So if you're hand entering it, you want to make sure your PRV is on the start side and the downstream of the PRV is on the outside. If you have them reversed like this does, it's not going to be able to attribute the pressure differential correctly, and it's going to cause some issues for your calculation. So that concludes the approach of handling PRVs in the Revit environment as well as on the desktop environment, and hopefully explains a little bit about how you might go about using them.